Hello viewers, welcome to the session on decision tree classifier in machine learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. So, firstly let us look at the definition of decision trees, which are a non-parametric supervised learning method used for classification and regression. The goal here is to create a model that predicts the value of a target variable by learning simple decision rules inferred from the data features. And a CART, which stands for a classification and regression tree, is a predictive model which explains how an outcome variable's value can be predicted based on the other values. And here in a CART output is a decision tree where each fork is split in a predictor variable and each end node contains a prediction for the outcome variable. So now let us look at the formula that we use in our decision tree classifier. And before moving ahead, let me tell you, in decision tree classifier we have two criterions. One is entropy and the other one is Gini index. And in order to understand these two, we have to understand what is information gain. And don't worry, even if you don't understand these terms here, it is going to be completely clear in the upcoming slides. So before moving ahead, let us quickly have a brief information about entropy, Gini and information gain. When it comes to entropy, it is nothing but a measure of disorder in the data set. And in the simple statistical language, it is a measure of randomness in the information being processed. And the higher the entropy, the higher is the difficulty to draw any conclusion from that information. So the simple thing that you have to keep in your mind is that in a data set, if the higher is the entropy, then it is difficult to draw any conclusion. And the formula for the entropy is given as summation of negative p log 2p. Here it is taken as negative because log 2 is going to provide us a negative value. So by applying negative, it is going to give us a standardized absolute value. And after that, and before moving to Gini index, let me just quickly explain you about the information gain. And it is just the opposite of entropy. In entropy, we have seen that higher the entropy value, it is difficult to draw any conclusion. Whereas in information gain, higher the information you have, higher we can have a probability of drawing conclusion. So it is just a reverse of information gain. So information gain has to be maximum. And when it comes to the Gini index criterion, it is used only when the target variable is a binary variable. So we use Gini index when our target variable is a binary variable. And the formula for the same is 1 negative summation of p square ci, where probability of ci is the probability or percentage of class ci in a node. So let us understand how this decision tree classifier works. For this, we are considering this example. If you are able to understand this example, then don't worry. You are clear with the concept of entropy and information gain. Once you understand entropy and information gain, then Gini coefficient is nothing for you. So let us see this example. We are considering this data set and we are going to predict whether we are going to play golf or not. And the parameters which are determining it are outlook, temperature, humidity and winding. And after the complete classification, our decision tree classifier is going to give this decision tree. Let us look at the internal working which is going to work inside it. So firstly, dealing with the entropy criteria, we need to find the entropy of the overall data set. For that, we have already discussed the formula that it is entropy is equal to negative p of log p. And here, what does this p indicates? Let me tell you. For that, we have to consider this data set in which for the overall data set we are considering how many yes are there and how many no. That is, at how many times we are going to play the golf and how many times we are not going to play the golf. And same thing has been substituted in this formula. So the entropy of not playing is 5 and entropy of playing is 9. So in total there are 14 records. So we are calculating the entropy for the overall data set, and here it is 5, and the probability of it is 5 by 14 and it is 9 by 14. By calculating it we get these decimal values, and again applying this to entropy formula we get 0.94 as the entropy for the overall play golf. After finding the entropy of the overall data set, let's look at the entropy of outlook. How it has been calculated? In outlook we are having only 3 different values. Let me show this in the dataset table. See, in outlook we are having only 3 distinct values, that is rainy, overcast and sunny. Same has been classified in this dataset also, where in output, and instead I have further divided it in sunny how many yes are there and how many no are there, and for the overall sunny how many records are there. I have taken down this. Now see, what I am doing I am calculating the entropy of play golf given that outlook. So the formula is same for the entropy, just we are multiplying the entropy to the probability of each of this outlook subsets of outlook. That is, probability of sunny is nothing but 5 out of 14. Same has been reflected here. Similarly, probability of overcast is 4 out of 14 and probability of rainy is 5 out of 14. And entropy of 3, 2, we have already discussed how we are going to calculate the entropy. So similarly we are calculating the entropy of the same, and here also we are calculating the entropy. Then finally we are getting the entropy of playing golf given of outlook is equal to 0.693. So this was 2 steps. First, calculating the entropy of overall dataset, then subpart of the dataset, and now how to know the information gain of each of these parameters. For that we are having the formula information gain is equal to entropy of the overall dataset minus entropy of the particular dataset. So how it has been calculated? 0.940 minus 0.693. This is the information gain for the outlook. See, we have calculated it as 0.247. Similarly, it has been calculated for each of these parameters, temperature, humidity and windy, and its values are reflected here. Now, we have already discussed in the formula session that if the information gain is maximum, then it is easy to classify more. If the information gain is less, then it is very difficult to classify. So from looking into the table, we can clearly say that outlook is having the highest information gain as of now. So our first node is going out to be overcast, and when I selected overcast and I have classified it into further smaller data set, then I have observed that no matter what is the condition of temperature, humidity and windy, we are going to play golf. And it has been learned by the decision tree classifier also, and same has been reflected in the first case. Then again we go for humidity. While observing to humidity, see here in sunny, for high we are playing the golf and for high we are not playing golf. So here clearly we are not getting what is going out to be with humidity. So we switch to the next highest coefficient, that is windy, and hence we classify it into this sunny into windy. On the basis of windy, I have broken down the dataset into further smaller dataset considering only sunny parts, in which we are playing golf, which is depending on only windy. So on the basis of windy we have classified it. Similarly, after that we are going to look at humidity. On the basis of humidity we are getting high and low, and obviously if it is raining and if it is humid and humid is very high, then we are not going to play golf. and if it is raining and the humidity is normal, then definitely we are going to play the golf. This was the working behind decision tree classifier. For a quick look, you can look into these conditions, and I want you, if you didn't understand it, go back and re-look into it and understand it clearly. There's nothing in this concept, only you have to understand three key terms that are entropy, information gain, and Gini coefficient, Gini criterion. When entropy is high, classification is different. Entropy and information gain are inversely proportional. So if information gain is very high, then classification will be easy. And when it comes to Gini criterion, then Gini criteria is used only when our outlook is having only two values, either true or false, for the binary, as we have discussed in the formula section. So let us now quickly look at the pros and cons of the decision tree classifier. When it comes to its advantages, it does not require normalization and scaling of data. And to add on, missing values in the data does not affect the process of building a decision tree to any considerable extent. And compared to all other algorithms, decision trees requires less effort for data preparation during pre-processing. On the flip side, when it comes to its disadvantages, it involves higher time to train the model, and even a small change in the data can cause a large change in the structure of the decision tree, causing instability. Okay, before jumping into the practical implementation of decision tree classifier, let us look at the general part flow. And I'm pretty sure you have been used to it, and I think I don't need to explain it again. The only change comes at step number 5, where we have to implement decision tree classifier algorithm on our training dataset. So finally, it's time for your favorite hands-on session of decision tree classifier in machine learning. So in this practical session also, we are working on the same dataset so that we can understand the concept really well. So that's why I have already imported all the important libraries and read the dataset. The dataset is same of purchasing on the basis of age and income. And now I am segregating my dataset into dependent and independent variables. See, X represents independent variables and Y represents the dependent variable. It has been successfully executed. Now I am splitting my dataset into training and testing model using train test split class, and it has been successfully executed here. X train, X test, Y train and Y test. We have got the values. Now since we can see that in independent variables there are two columns, one is age and another one is income of the employee, and there is huge difference between both of them. So in order to bring them down, we are using standard scalarization. Let me execute this. See, it has been successfully executed. Now the difference has been reduced. Now here is the main chunk of code to understand decision tree classifier. From sklearn package, I am using tree class, and in the tree class I am importing decision tree classifier class, and I am creating an object of decision tree classifier, and the criteria which I am giving is entropy, and I have set the random state as 0. Now I am fitting my training dataset into this decision tree classifier algorithm. See, it has been successfully executed. Now I am going to predict the dependent variable of testing dataset on the basis of independent variables of the testing dataset using decision tree classifier. I have executed the same. It has been executed successfully. Let's check. This is our predicted value. Y test represents the actual value. You can see it's a good prediction. Now let us analyze our prediction through confusion matrix. It has been successfully executed. It's stored in CM. Let's see. 6 plus 3. 9 errors are there, which means our accuracy score is going out to be 91%. You can see. And now let's have
visualization of our prediction. So I am plotting the graph. It has been successfully executed, and you can see the graph, how overfitting it is.
So as usual, I have included code snippet for your fast revision, and before ending up, I want you to try implementing decision tree classifier by changing the criterion parameter to Gini index, and I want you to observe the results on the same dataset. And you can pause your video here and can take the screenshot of the same for your future reference. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.